Hi everyone, welcome to experiment 3. This time we're looking at chromatography, in particular the chromatography of the colours in sweets. Now, in addition to the stuff you've got in the bag, which is one sheet of filter paper and 2 universals, you'll need a couple of sweets. As I mentioned in the instructions, green Skittles seem to be the best, but you can use another one if you want. You will also need a container with some clean water, a pencil and a pair of scissors. A Pasteur pipette will be useful but is not essential. You can use one of the ones you had in an earlier experiment. When it comes to applying the colours to the paper, you need something to be able to get a small spot. You could use the pencil tip perhaps, or maybe a cocktail stick. I'm actually going to be using a wooden skewer. The first thing we'll do is set about extracting the colour from the Skittles. So what we do is we open one universal, drop 2 Skittles in and put in a small amount of water. You don't need to measure it, but you do want to make sure it's a very small amount to get the most concentrated colour you can. Don't put in enough to cover the sweets. You can just shake it around so it washes over both of them. So we'll put that to one side for a few minutes and prepare the paper. You take the scissors and cut yourself a strip of paper. Try to make sure it's reasonably wide, but not so wide it won't fit inside your universal. That should be okay. We'll have a look. Yes, that's fine. I'll just trim it a bit. So now you need to make a pencil mark about 1 centimetre or so from the bottom of the paper. This will let you know whereabouts you have to put the colour. Now for the colour. You can see we have a decent amount of colour in solution, and the sweets themselves are pretty much white. So what we do is we apply a small amount to the paper, but only a small amount. Now, as I said, I'm going to be using this wooden skewer. All I'm going to do is to dip it in and then dab it onto the paper. As you can see, there's a blob of colour. It's not very much, so it's best to let it dry if you can. Either blow on it or use a hairdryer to speed it up if you want. Then you can see about adding 2 or 3 more droplets. The more you add, the more intense the colour, and so the better the separation will be. But your patience may not stretch that far. If you're using a Pasteur pipette, that's okay. Don't squeeze it, you just touch it very gently onto the surface of the liquid and then dab it onto the paper. The smaller the blob, the better the separation. Now this one's not going to be perfect, but we'll leave it at that. Now what you want to do is to put a very small amount of water in the bottom of your other universal. You can see the bottom's got a conical depression, so you want to fill it to no more than the top of that. That'll be plenty. The key point is that the blob of colour on the paper must be above the surface of the liquid, otherwise it'll wash off into the water. So now what we're going to do is we're going to get our piece of paper with the blob of colour on it and gently drop it in, place it in. It may well settle down into the water a little bit as it loses its strength as getting wet, but hopefully the blob of colour should stay above the water level. Now you should see very soon that the liquid starts to go up the paper by capillary action. You can see mine's got to about here already, and in a little while you should see the colour starting to separate. Where you did have a single green blob, you should now see it going blue at the top and yellow at the bottom. Anyway, we'll leave this for a few minutes. When the water's got a significant way up the paper, you don't have to let it reach the top. But when it's got high enough that you've lost patience, we'll take it out and have a look. First thing you do is you mark where the water has reached with a pencil. I'll explain the reason for that later. Now you can see round about here the area is blue, and down there you've got yellow. They're both a bit smeared out, but you can clearly see there are 2 different colours. Now, the reason for the markings is that it's possible to measure the distance from here to here, where the colour travelled. And you can measure how far the water has travelled as well, because you marked where your colour dye started at the beginning and you also marked where the solvent front reached at the end. If you divide the distance the colour travelled by the distance the solvent travelled, you get a figure called the RF value. And the important thing is that this is always the same for the same dye as long as you're using the same solvent of paper. Now looking at this one, the blue has got an RF value around about 0.8 and the yellow around about 0.1. And this is a very useful diagnostic tool. If you have two blue dyes that, with the same setup and the same solvents, etc., produce the same colour spots and they have the same RF values, then you can almost be certain that they are in fact the same dyes. So it allows you to actually identify a specific substance. And more sophisticated versions of this technique are widely used for forensic and other analysis of all sorts of coloured materials, such as car paints and the like.